Hey guys, welcome to another video, and today we'll be looking at work and energy, right? So work is defined as the force causing an object to move, right? So when you do work in physics, you actually causing the object to actually change position or to displace or to move, right? So the equation that links work is equal to force times distance times cos theta, right? So let's see what cos theta is, right? So cos theta tells us it's the angle between the force that's causing the motion and the distance in which it's moving, right? So if we look at this example here, we have a box being pulled slanted with F force, right? And the direction that it causes it to move is actually in a horizontal plane. So it's going to pull it against the floor, right? So because the angle created between the direction that it's going horizontally and the force, theta, right? Then we add theta there, right? Because what that gives us, it gives us that the force that you're going to act, that the work that's going to be done would be less if it was in this manner, right? So if it's the same force that's being pulled, but this time it's being pulled the same direction as in which you're pulling the object, the direction in which it's going, so they're both parallel, right? So parallel force and direction is parallel to each other, so the angle created is 0, right? So in this case, theta is 0, right? And cos of 0 is 1. So we basically just have force times distance, right? So this is a good example of showing that to do more work with the same force, you apply the force in the same direction in which you want the object to go. If there's an angle created, then you're going to do less work with that specific force, right? So that's what work is, and work has a unit of joule or Newton meter, right? So we can use Newton meter or normally just commonly see the joule, right? Now, energy. Energy is the ability to do work, right? So once you're doing work, which is applying a force to move something, then you're using energy, right? And we have two types of mechanical energy, which are the potential energy, gravitational potential, and our kinetic energy, right? But we have different forms of energy, like our chemical energy, or potential energy, or nuclear energy, right? Or light energy, heat energy. So those things are forms of energy, the forms that energy do exist, right? So chemical energy, the energy you get from your food when you eat, right? We have elastic energy, right? That's called the energy that it stores in order for elastic objects to stretch and come back to its normal position, right? And we have heat energy, which is the thermal energy, right? So that's the radiation that is felt from objects that are rubbed together or stored from our sun, that's produced from our sun and such, right? But we're only going to focus on the mechanical energy, which entails gravitational potential energy and kinetic energy. So let's look at the gravitational potential energy, right? So this is normally abbreviated PE, right? So this is the energy an object has when it is above the surface of the ground, right? So the object can be moving, right? But once it is above the surface of the ground, then it has gravitational potential energy. And what I normally like to define this energy as is the energy that the object has in order for it to, if everything else is removed from it, then it causes it to fall, right? So if the object has the potential of falling from where it is, then it has gravitational potential energy, right? So we notice that PE is equal to mass times gravitational acceleration times h, right? So the h here is important. If we don't have the height above the earth, then we're not able to have potential energy. So once the object reaches the surface of the earth, then we have no potential energy, right? And then our kinetic energy. So kinetic energy is once your object is moving, then it has a kinetic energy. So it's the energy an object has due to its motion, right? And it's also abbreviated, in this case, KE, which is half the mass, m, times velocity squared, right? So therefore, it's important that you have to be moving. So if the object is not moving, then it doesn't have a velocity, so therefore it will not have a kinetic energy. But once it's moving, it's going to have a kinetic energy, right? So because these are two types of mechanical energy, then the total mechanical energy is your potential energy plus your kinetic energy, right? And this only applies, right, if we're ignoring the fact that we have the loss of heat energy, which is something that we not able to actually control, right? So this is just under the basis that there's no heat lost, right? So no energy lost as heat, right? And for physics, since this is physics, we always have some law to govern our concepts, right? So we have the law of conservation of energy, right? And this law states that energy is not able to be created or destroyed, but we're only able to change the energy forms from one form to another, right? So what that is saying is, let's take, so the energy conservation is like a cycle, right? So let's say we start off with electrical energy that you get from your socket, right? So you use it in your microwave to get heat energy, light energy, right? So those forms of energy, when you add up those energy, you will get back the electrical energy, right? So we don't create energy, we only recycle energy to change it from one form to another, right? So that's why the sun and the wind and the hydroelectricity, they are known as renewable energy, because once we use them to get electricity and to change it to other forms of energy, right, we still have those resources that can actually give us more. But with crude oil, right, once we use it, it takes too long, millions of years, to actually get back crude oil through that cycle process, right? So that's the reason why, right? So let's look at a scenario that we can actually apply the conservation of energy with. All right, so the principle that we're going to use is hydroelectricity, right? So we're going to use a waterfall, right? Now we're going to assume that the water at the top is relatively minimal, not moving. So we're going to say at the top of the cliff that the water is steady, right, until it starts to fall off the cliff of a height h, right, till it reaches the bottom of the cliff here, right? So let's look. So in our system here, we're going to state, using numerical values just for this purpose, that the total energy in our system here is 1,000 joules, right? So remember, we're only looking at total mechanical energy with PE and KE, right? So at the top of this system, right, then PE and KE, our conservation of energy states that we cannot create more than this or destroy this amount of energy. It only has to be transferred between forms, right? And the forms that can be transferred in this situation is PE and KE, right? So at the top here, right? So remember, at the top, we're going to ignore that the water is moving because it has minimal movement. So that means all our energy at the top is due to potential energy. Alright, so we have zero kinetic energy there. Alright, and that's because we are at the maximum height of the cliff, so PE is at its max. So we can say PE is at its max, while KE be at its min, because it's not moving there, right? So let's move now to the middle section, right? So at the middle of the cliff, so PE, now at the middle, since we now reduce the height to a half, then that means our potential energy has to be reduced to a half, right? And since that is reduced to a half, our total system needs to be 1,000. So if this is 500, then PE is also 500 as well, right? And then at the bottom, so at the bottom where the water is touching the ground, right, we remember that PE is only present when it's above the ground. So now since the water is touching the ground, then PE is 0 joule, and then KE would be 1000. So that's our max, and PE here would be at its min. Alright, so this shows us the conversion or the transformation from one form of energy to the next, right? And throughout each point, we notice that the total energy, if we add PE and KE, is 1000, 500 plus 500, 1000, 0 plus 1000, 1000. Right? So we did not create any energy, or we did not destroy any energy, right? So it only transferred between potential and kinetic as it goes. So we notice potential starts from its max, it starts to reduce to, it reaches its min. Kinetic starts from its min, starts to increase to its maximum value. Alright? So that's it about energy and work, guys. Thank you for tuning in today, and hope you understand something, and see you guys next time.